Welcome to the Astrum Discovery Network, where we journey through the vast cosmos to unravel the mysteries of our origins. We are traveling back through billions of years, seeking the very moment when time and space began their incredible existence. This is not just a story of physics, but a chronicle of human curiosity, pushing against the boundaries of the unknown. For centuries, humanity believed the universe was eternal and unchanging, a static stage where celestial events played out forever. Our story begins not with a complex equation, but with Georges Lemaître, a humble priest contemplating the divine in 1927. He was the first to propose a radical idea, suggesting that the universe was not static, but was actually growing. Lemaître called this the Primeval Atom, a single point containing all the matter and energy that would ever exist. The scientific community was skeptical, finding the concept of a distinct beginning too similar to religious stories of creation. Even the great Albert Einstein initially dismissed the idea, believing that the universe had to be eternal and unchanging. However, the mathematics of general relativity allowed for an expanding universe, a truth that Einstein would eventually come to accept. Enter Fred Hoyle, a brilliant but stubborn astrophysicist who became the leading champion of the opposing static universe theory. Hoyle argued for a steady-state universe, where new matter is constantly created to fill the gaps as the universe expands. During a radio broadcast, Hoyle intended to mock Lemaître's idea, searching for a phrase to make it sound ridiculous. He dismissively called it the Big Bang, a derogatory name that was meant to highlight the absurdity of the idea. Ironically, the catchy name stuck, becoming the official scientific term for the very theory Hoyle tried to destroy. While theorists argued in lecture halls, the true evidence was waiting to be discovered in the silent observatory domes. Edwin Hubble, an astronomer with a keen eye, began observing distant nebulae, which we now know as other galaxies. He noticed a strange phenomenon in the light coming from these galaxies, a shift towards the red end of the spectrum. Just as a train whistle lowers in pitch as it moves away, light waves stretch out as a source recedes. Hubble realized that almost all galaxies were moving away from us, and the farther they were, the faster they moved. This linear relationship provided the first hard evidence that the universe was not static, but was actively expanding in all directions. For Lemaître, this was the smoking gun, observational proof that his primeval atom theory was grounded in physical reality. If the universe is expanding today, then rewinding the clock means everything must have once been compressed into a tiny point. Decades later, in 1964, two radio astronomers at Bell Labs stumbled upon the next great piece of the puzzle. They were trying to calibrate their sensitive antenna, but were plagued by a persistent, annoying background hiss they couldn't eliminate. They checked everything, suspecting urban interference or even nuclear testing fallout, but the mysterious signal remained constant everywhere. Desperate for an answer, they even blamed a pair of nesting pigeons and their droppings, which they called white dielectric material. After evicting the birds and scrubbing the antenna clean, the noise persisted, coming uniformly from every direction in the sky. When they called Princeton researcher Robert Dickey, he famously hung up and told his colleagues, "Boys, we've been scooped." That annoying hiss was the cosmic microwave background, the thermal afterglow left over from the Big Bang itself. It was the echo of the universe's first breath, a relic from a time when the cosmos was a hot fog. As the universe expanded and cooled, this light was finally released, traveling for billions of years to reach our antennas. With the discovery of the cosmic microwave background, the steady-state theory was effectively dead. The Big Bang had won. However, every theory has its limits, and the Big Bang model was facing a catastrophic problem at its very core. When physicists tried to calculate what happened at the exact moment of time equals zero, their mathematics completely broke down. They encountered a singularity, a point of infinite density and temperature, where the known laws of physics cease to function. General relativity works for stars, and quantum mechanics works for atoms, but at the singularity, they violently disagree. In 1980, physicist Alan Guth proposed a solution to smooth out the issues of the standard Big Bang model. He introduced inflation, suggesting the universe expanded exponentially in a fraction of a second, faster than the speed of light. Think of it like a wrinkled balloon suddenly inflated. The surface becomes smooth, explaining why the universe looks uniform everywhere. Stephen Hawking took a different approach, challenging the very idea that there was a beginning in the traditional sense. He proposed the no-boundary proposal, asking what lies south of the South Pole. The answer is simply nothing. In his model, time behaves like space near the beginning, meaning there was no sharp point of creation, just existence. Others suggest the Big Bounce, where our Big Bang was merely the recoil from the collapse of a previous universe. Roger Penrose proposes that the heat death of one universe becomes the Big Bang of the next, an eternal cycle. Then there is string theory, which attempts to unify all forces by suggesting particles are actually tiny vibrating strings. M-theory takes this further, imagining our universe as a membrane floating in a higher dimensional space alongside other universes. Some physicists believe the Big Bang was caused by the collision of two such brains, sparking the energy we see today. From a priest's intuition to multidimensional math, our understanding of the Big Bang has evolved into a complex, beautiful tapestry. We have traveled a long way from the primeval atom, yet the ultimate question of why remains as elusive as ever. As we gaze into the past, we are really looking into a mirror, searching for our own place in this story. Thank you for joining the Astrum Discovery Network on this journey through time. The universe is waiting for you. Until next time, keep looking up. Every star in the sky tells a story of nuclear fusion and gravity battling for dominance over billions of years. Galaxies like our own Milky Way are island universes, hosting billions of stars and potentially countless worlds with life. Black holes remain one of the most extreme environments, testing the limits of our understanding of space and time. Nebulae are the stellar nurseries where new stars are born, from the remnants of those that died long ago. Comets are icy wanderers from the dawn of the solar system, carrying the pristine ingredients of our cosmic history. Our Sun provides the energy for life, a stable nuclear reactor that has burned brightly for nearly 5 billion years. Earth is the only home we have ever known, a unique oasis of life in a vast and hostile universe. Human exploration has taken us beyond our atmosphere, challenging us to adapt and survive in the vacuum of space. Mars beckons as the next frontier, a planet that may once have harbored liquid water, and perhaps even life. Saturn's rings are a jewel of the solar system, a dazzling display of orbital mechanics and natural beauty. Jupiter acts as a guardian, its massive gravity shielding the inner planets from many dangerous asteroids and comets. The Moon is our constant companion, influencing our tides and stabilizing our planet's tilt for billions of years. Cosmic impacts have shaped the history of worlds, bringing both destruction and the necessary ingredients for life to evolve. New telescopes allow us to peer deeper into the past, revealing the first galaxies that formed after the Big Bang. Dark matter remains an invisible scaffold, holding galaxies together with its gravity, yet evading all our attempts at detection. Dark energy is the mysterious force driving the accelerated expansion of the universe, pushing galaxies apart faster every day. The quantum world of atoms underpins everything, proving that the rules of the very small dictate the structure of the large. We are made of star stuff. The complex molecules of life were forged in the hearts of dying stars. The complexity of the human brain rivals the complexity of the cosmic web, a universe within our own skulls. Our civilization is a fleeting moment in cosmic time, a brief spark of consciousness in a vast, dark arena. Life on Earth is resilient and diverse, adapting to changing conditions over eons of geological and climatic history. The depths of our oceans remain as mysterious as deep space, hosting alien-like creatures in complete darkness and pressure. geological forces constantly reshape our planet, recycling the crust and releasing gases that maintain our protective atmosphere. We are now realizing our impact on this planet, understanding that our future depends on preserving this fragile balance. The dream of becoming a multiplanetary species drives us forward, ensuring the survival of humanity beyond Earth. International cooperation in space demonstrates that we can work together to solve complex problems for the benefit of all. We listen to the whispers of the cosmos, hoping to catch a signal from another civilization among the stars. Mathematics is the language of the universe, allowing us to converse with nature and understand its deepest laws. In laboratories around the world, dedicated researchers push the boundaries of what is possible, seeking new breakthroughs daily. We smash particles together at near light speed to recreate the conditions of the Big Bang in miniature. Discovering the Higgs boson confirmed how particles gain mass, a crucial piece of the standard model of physics. Gravitational waves allow us to hear the universe, detecting the violent collisions of black holes across vast distances. Neutron stars are so dense that a teaspoon of their material would weigh billions of tons on Earth. Supernovae are the cosmic forges that create heavy elements like gold and silver, scattering them across the galaxy. Far beyond the planets lies the Oort cloud, a spherical shell of icy debris marking the edge of our system. Voyager 1 carries a golden record of humanity, a message in a bottle floating in the cosmic ocean. Our solar system formed from a collapsing cloud of gas and dust, eventually giving rise to the planets we know. Life has faced extinction many times, yet it always finds a way to recover and evolve into new forms. Our ancestors looked at the same stars and wondered about their meaning. Starting the journey of discovery, we continue. Ancient civilizations built monuments aligned with the heavens, demonstrating their sophisticated understanding of astronomical cycles and movements. Galileo changed our perspective forever when he pointed a spyglass at the sky and saw moons orbiting Jupiter. Newton unified the falling apple and the orbiting moon under one universal law of gravity, connecting heaven and earth. Understanding light was key to unlocking the composition of stars, realizing they are made of the same elements as Earth. Future technologies, like quantum computing, may help us simulate the universe in unprecedented detail, revealing hidden truths. Artificial intelligence is now aiding astronomers, sifting through massive amounts of data to find patterns humans might miss. Asteroid mining could provide the resources needed to build massive structures in space without depleting Earth's environment. A base on the moon will serve as a gateway to the rest of the solar system, a stepping stone. Terraforming other worlds is a distant dream, but one that captures the imagination of scientists and visionaries alike. Interstellar travel remains the ultimate challenge, requiring physics and engineering far beyond our current capabilities and understanding. The Fermi paradox asks a haunting question. If the universe is so vast and old, where is everybody? Finding life elsewhere would be the most profound discovery in history, proving we are not alone in the dark. Advanced civilizations might harness the power of entire stars, building megastructures that we can only dream of. Wormholes are theoretical shortcuts through space-time, potentially allowing for travel across the universe in a human lifetime. Time travel remains a staple of science fiction, but the laws of physics suggest it may be impossible. The multiverse theory suggests there could be infinite versions of you, living out every possible choice you made. The most likely end of the universe is the heat death, where all energy dissipates and time loses meaning. Alternatively, the Big Rip could tear every atom apart as the expansion of the universe accelerates to infinity. But perhaps the end is just a new beginning, a cycle of death and rebirth that lasts forever. Why is there something rather than nothing? This philosophical question underpins all our scientific endeavors and inquiries. Passing on our knowledge to the next generation ensures that the flame of curiosity will never be extinguished. Books preserve the wisdom of the past, allowing us to converse with the greatest minds who ever lived. The internet connects us all, creating a global brain that accelerates the pace of discovery and innovation. Art and science are twin expressions of the human spirit, both seeking to interpret and understand the reality around us. The universe has a rhythm and a melody, a cosmic symphony played out on the grandest scale imaginable. Astronomy is a humbling experience, reminding us of our smallness and the preciousness of our brief existence. Yet, in our smallness lies our greatness. We are the part of the universe that has come to know itself. The future is not written, it is ours to create, guided by the light of reason and the spirit of exploration. Under the same sky, we are one people, united by our shared heritage on this pale blue dot. Curiosity is the engine of progress, the drive that led us out of the caves and to the stars. Perseverance in the face of failure is what separates successful discovery from forgotten dreams and lost opportunities. The universe is not just true, it is beautiful, filling us with awe and inspiring our deepest creative works. Science is the pursuit of truth, a candle in the dark that illuminates the path forward for humanity. As the universe expands, it carries our dreams and our potential with it into the infinite unknown. We are stardust, contemplating the stars, a loop of consciousness that brings meaning to the mechanical cosmos. The mysteries of gravity and time continue to challenge us, inviting us to look closer and think deeper. Venus serves as a warning of runaway greenhouse effects, a reminder to care for our own planetary atmosphere. Mercury, closest to the Sun, endures extreme temperatures, a testament to the harsh diversity of planetary environments. Uranus rolls on its side, a mysterious ice giant that challenges our models of how planets form and evolve. Neptune's supersonic winds remind us of the dynamic and violent weather systems that exist on other worlds. Pluto, though small and distant, is geologically active, showing that even the outskirts of the system are alive. The Kuiper Belt holds the frozen remnants of the solar system's birth, waiting to be studied and understood. Andromeda is our galactic neighbor, destined to collide with the Milky Way in a cosmic dance billions of years hence. Globular clusters are the retirement homes of stars, containing some of the oldest stellar inhabitants in the universe. Pulsars act as cosmic lighthouses, their precise timing allowing us to map our location in the galaxy. Quasars are the brightest objects in the universe, powered by supermassive black holes devouring matter at incredible rates. Gravity acts as a lens, magnifying distant galaxies and allowing us to see further back in time than otherwise possible. Hawking radiation suggests that black holes are not truly black, but slowly evaporate over unimaginable timescales. Quantum entanglement connects particles across space instantly, a phenomenon Einstein called spooky action at a distance. Heisenberg's uncertainty principle tells us that at the smallest scales, nature is inherently probabilistic, not deterministic. Schrödinger's cat illustrates the paradox of quantum superposition, where reality is not decided until it is observed. While we cannot travel back in time, we travel into the future every second of every day. Moons like Europa may hide vast oceans beneath their icy shells, potentially harboring life forms completely unlike our own. On planets like Neptune, extreme pressure might cause it to literally rain diamonds, a treasure beyond reach. Earth's magnetic field protects us from the solar wind, creating the beautiful auroras while shielding our atmosphere. A total solar eclipse is a cosmic coincidence, where the moon perfectly covers the sun, revealing its corona. The gravitational dance between the Earth and Moon drives the tides, influencing the rhythm of life in the oceans. The tilt of our planet gives us seasons, driving the cycles of growth, harvest, dormancy, and rebirth. Life is a journey of adaptation, a relentless march from simple cells to complex creatures capable of spaceflight. Mastering fire was the first step in harnessing energy, leading eventually to steam engines, electricity, and nuclear power. The invention of the wheel set humanity in motion, shrinking distances and connecting disparate cultures and economies. Writing allowed us to store knowledge outside our brains, creating a collective memory that spans thousands of years. The printing press democratized knowledge, sparking revolutions in science, religion, and politics that shaped the modern world. Harnessing electricity banished the night, powering our industries and connecting us instantly across the globe. Taking to the skies fulfilled an ancient dream, giving us a new perspective on our world and its borders. Medical breakthroughs have doubled our lifespans, allowing us more time to explore, create, and understand our universe. The silicon chip is the engine of the information age, processing data at speeds our ancestors could never imagine. Robotics promises to free us from dangerous labor, while raising ethical questions about the nature of work and consciousness. Virtual reality allows us to explore worlds that do not exist, expanding the boundaries of human experience and imagination. Transitioning to renewable energy is essential for our survival, aligning our technology with the natural cycles of the planet. A circular economy mimics nature, where there is no waste, only resources for the next cycle of growth. Peace remains our most elusive goal, yet it is the necessary foundation for a sustainable future in space. Looking inward is as important as looking outward. Understanding our own minds is key to understanding the universe. Love and connection give meaning to our lives, providing the emotional fuel to keep exploring the cold cosmos. Our families are our personal solar systems, orbiting around shared history and the gravity of mutual affection. Community is the glue of civilization, allowing us to achieve together what would be impossible for us alone. Teachers are the unsung heroes, planting the seeds of curiosity that will blossom into the discoveries of tomorrow. Healers dedicate their lives to preserving ours, fighting the entropy of disease and injury with skill and compassion. Farmers connect us to the land and the sun, converting solar energy into the sustenance that fuels our civilization. Engineers turn dreams into reality, building the bridges, rockets, and networks that define our modern existence. Artists remind us that we are not just biological machines, but beings capable of perceiving and creating beauty. Explorers push the boundaries of the known map, driven by an insatiable desire to see what lies beyond. Play is the natural state of learning, where imagination runs free and the laws of physics are tested. Age brings wisdom, the accumulated experience of a life lived witnessing the constant change of the world. Death is the final frontier for the individual, a return to the star stuff from which we were made. Birth is a miracle of biology, the continuation of a genetic line that stretches back to the first cells. In the silence of the night, we can hear the echoes of the universe, whispering its secrets to us. Storms remind us of the power of nature, forces that are far greater than our ability to control. A rainbow is a promise of light returning, a physical manifestation of the spectrum that reveals the universe's composition. Each snowflake is unique, a crystalline masterpiece formed by the physics of water and the cold of the atmosphere. Deserts are landscapes of time, where the wind sculpts the earth into forms that change with every passing day. Water is the lifeblood of our planet, constantly flowing, evaporating, and raining down in a cycle of renewal. Caves are nature's time capsules, preserving the geological history of the earth in layers of stone and mineral. Coral reefs are the rainforests of the sea, teeming with a diversity of life that rivals any ecosystem on land. Migration is a feat of endurance and navigation, guided by the magnetic field and the stars in the sky. Whales are the giants of the deep, intelligent and social beings that sing songs across entire ocean basins. Even the smallest insects play a vital role, demonstrating the power of collective effort and specialized roles in nature. A flower blooming is a triumph of biology, a display of color and scent designed to ensure survival. Trees are the lungs of the earth, standing witness to centuries of history while silently providing the air we breathe. Fungi connect the forest in a wood-wide web, recycling nutrients and supporting the growth of vast ecosystems. Microbes are the invisible rulers of the world, essential for digestion, decomposition, and the very origin of life itself. Viruses straddle the line between living and non-living, driving evolution through the constant battle for survival and adaptation. Cell division is the fundamental process of growth, a complex dance of chromosomes that builds every living organism. Our genes are the instruction manual for life, written in a 4-letter alphabet that spells out who we are. The microscope opened up a new universe of the small, revealing the teeming life in a single drop of water. The telescope opened up the universe of the large, showing us that we are just a speck in the cosmos. Maps of the sky were the first GPS, guiding sailors across oceans and travelers across deserts for millennia. The compass harnessed the Earth's magnetic field, giving us direction when there were no landmarks to be seen. Time is the most precious resource we have, slipping through our fingers like sand, never to be recovered. Calendars organize the chaos of time, aligning our lives with the cycles of the sun and the moon. Atomic clocks measure time with incredible precision, essential for GPS and the synchronization of the modern digital world. The speed of light is the cosmic speed limit, dictating how fast information can travel across the universe. Einstein's famous equation showed that mass and energy are interchangeable, unlocking the power of the atom for us. The power of the atom brings great responsibility, capable of destroying civilization or providing clean energy for all. Nuclear energy remains a controversial yet powerful tool, a testament to our ability to manipulate the fundamental forces. Solar power harvests the fusion energy of the sun, a clean and infinite source that can power our future. Wind is the movement of the atmosphere, driven by the sun, a kinetic force we have harnessed for centuries. Hydroelectric power captures the energy of the water cycle, using gravity to generate electricity for millions of homes. Geothermal energy taps into the heat of the earth itself, a remnant of its fiery formation billions of years ago. Electric transport is quiet in our cities and clean in our air, a technological shift towards a more sustainable existence. Green cities integrate nature into the urban fabric, creating healthy environments for people and wildlife to thrive together. Sustainable agriculture produces food with less water and land, ensuring we can feed a growing population without destruction. Access to clean water is a fundamental human right, a challenge we must solve to ensure health and dignity. Vaccines are a shield against disease, a triumph of science that has eradicated terrible plagues from the human experience. Technology is transforming education, allowing students to visit Mars or the bottom of the ocean from their classrooms. Our story is still being written, a collective narrative of hope, struggle, and triumph on this beautiful planet. We are the Astrum Discovery Network, and we are honored to have you with us on this incredible journey. Don't forget to subscribe and like for more adventures into the unknown. Until next time, stay curious.